If you are still obsessing over prompt engineering in 2026, I hate to break it to you, but you're already behind the curve. The era of typing "act as an expert copywriter" or "take a deep breath and think step by step" as a legitimate engineering strategy, it's over. It was a gold rush built on sand. The top AI engineers at OpenAI, Anthropic, Google, and elite startups aren't spending their days writing clever paragraphs to coax a model into behaving. They've moved on. They are building harnesses. Here is the brutal reality we all have to face. A raw large language model is not an intelligent agent. It is a probabilistic next token predictor with zero persistent reasoning structure. Left to its own devices, a raw LLM is a chaotic mess. It forgets its goals, it loses its objective, it hallucinates status, it gets stuck in infinite loops, and under long context pressure, its brain completely collapses. Without a control structure, your multi-million-dollar AI agent is just autocomplete with a lot of confidence. In this video, we are breaking down the actual architecture being used right now to build truly autonomous, production-grade AI systems. We're pulling back the curtain on the 6-part harness architecture, the hidden operating system that turns volatile AI into bulletproof software. If you want to build things that actually work in the real world, drop the prompt templates. Let's build a harness. Think of it this way. The LLM, the actual AI model, is just the engine. It's raw, explosive horsepower. But if you bolt a V8 engine onto a wooden plank with no steering wheel, no transmission, no brakes, and no dashboard, you don't have a supercar. You have a death trap. The harness is everything else. It's the steering, the transmission, the brakes, the sensors, the memory, and the operating system. It is the deterministic cage we build around a chaotic, stochastic model to force it to do useful, reliable work. Write this formula down because it is the golden rule of modern AI development. Capability equals model times systems architecture. A mediocre, smaller model wrapped in an elite, production-grade harness will absolutely embarrass a massive, expensive, state-of-the-art model that's just being fed raw prompts. Why? Because in production, reliability dominates raw intelligence every single day. So, how do the pros actually build this? It comes down to a modern 6-part architectural framework. Let's dissect it layer by layer. First up is the execution loop. This is the agent's runtime brain cycle. If you just send a prompt to ChatGPT, it responds once, and the process dies. That's a chatbot. An autonomous agent needs to live in a continuous cycle of observe, think, act, evaluate, repeat. This is how systems like OpenAI Operator or Anthropic's Claude agents actually operate internally. The harness keeps the agent alive across hours or days, allowing it to plan a goal, try a solution, realize it failed, self-correct, and try again. Without an execution loop, your agent cannot recover from errors. It just trips over the first hurdle and gives up. But an execution loop is useless if the agent is paralyzed. That brings us to component number 2. The tool registry. LLMs are inherently weak. They can't browse the web reliably. They can't run code safely. They can't check your SQL database, and they can't send emails. A tool registry is a structured, heavily guarded map of capabilities given to the AI. The model never touches the real world directly. Instead, the harness says, here is a strictly validated JSON schema of tools you are allowed to call. The AI decides what it wants to do, but the harness decides how it gets executed, manages permissions, handles API retries, and sandboxes the environment so the AI doesn't accidentally wipe a production database. Now let's talk about the absolute silent killer in AI engineering, context rot. We've all seen the marketing hype. Our model has a 2 million token context window. Here's what they don't tell you. Bigger context windows do not solve reasoning degradation. They only delay it. As a conversation or a task gets longer, a phenomenon called lost in the middle occurs. The model's attention weakens, contradictions pile up, and its instruction adherence completely collapses. It literally gets confused by its own history. The context manager is the antidote. It acts as an aggressive editor for the AI's brain, It constantly compresses memory, summarizes older conversation turns, ranks information by semantic relevance, and injects only what is absolutely necessary for the current token window. Elite AI products look like chat apps, but underneath, they are highly sophisticated memory management systems. And where does that memory live? Component 4. The state store. Stateless agents are toys. If your agent relies on the system prompt to remember what it's doing, like typing, "You are currently on step 3 of 5" into the prompt, you are building a house of cards. Real systems treat the LLM as a completely stateless calculator. The actual state, the user's preferences, the completed tasks, the current workflow progress, is safely stored externally in something robust like Redis, Postgres, or a graph database. Every time the execution loop ticks, the harness fetches the state from the database, feeds it to the model, gets the answer, updates the database, and flushes the model's short-term memory clean. The fifth piece of the architecture is lifecycle hooks. Think of these as the security checkpoints and middleware of your AI system. Before the harness sends a prompt to the LLM, a pre-inference hook fires to scrub sensitive PII data or inject real-time guardrails. After the model responds, a post-inference hook fires to check for banned phrases, structural errors, or safety violations before the output ever reaches the user or the tools. Hooks give you absolute control over an otherwise unpredictable system. Finally, the place where 99% of amateur AI agents fail catastrophically, the verification interface. LLMs are pathological liars because they are designed to sound plausible, not necessarily to be correct. They will output broken code, wrong math, or hallucinated facts with absolute certainty. A production harness never takes an LLM at its word. It uses deterministic verification. If the agent writes code, the verification interface spins up a secure Docker container, runs unit tests on that code, captures the error log, and feeds it straight back into the execution loop for the AI to fix itself. If it's extracting financial data, the harness runs mathematical checks to ensure the numbers actually add up. That isn't prompting, that is rigorous systems engineering. Now, if you're wondering how engineers are connecting all these moving parts without writing thousands of lines of messy, brittle integration code, the answer lies in a massive shift that happened recently: the standardization of MCP, or the Model Context Protocol. Before MCP, every time you wanted to give an agent a new tool, whether it was connecting it to an IDE, a specific database, a browser, or a company API, you had to write custom, fragile wrapper code. It was a nightmare to maintain. MCP changed everything. Think of it as USB-C for AI agents. It creates a universal, standardized open protocol for how a model context layer talks to external data sources and tools. The harness handles the MCP security and routing, allowing agents to instantly and safely plug into entire ecosystems of tools without custom development. If you aren't building your harness around MCP interfaces yet, start now. Let's look at the big picture. The industry has gone through a brutal evolution over the last few years. We started in the prompt engineering era, where we thought we could just whisper the right words to make magic happen. Then we moved into the agent systems era, chaining prompts together. Today, we are firmly in the autonomous infrastructure era. The most valuable AI engineers in the world right now don't look like creative copywriters. They look like distributed systems engineers, infrastructure architects, and operating system designers. The next time you see someone selling a course on the top 10 prompts to automate your business, change the channel. The real leverage isn't in the perfect adjective. It's in the execution loops, the context managers, the verification layers, and the deterministic architecture you build around the model. Build harnesses, not prompts. If you found this breakdown valuable, hit that subscribe button. Drop a comment below with what you're currently building in your AI stack, and I'll see you in the next one. Keep building.